Hi, here are the answers to slide 28 of your digital notebook. There's also just a picture of the final answers, but if you want a step-by-step explanation, here you go. So make sure you have your periodic table with you. When you're drawing Lewis structures, the first step is to find your central atom, place that atom in the middle, in the center, and place all other atoms around it. So for your first example, HBr only has 2 atoms, so there's not a central atom. So then you just put one atom right beside the other one. It's a little darker so you can see it. All right, step 2 is to count up the total number of valence electrons that you have. So hydrogen has 1 valence electron from the periodic table. Bromine has 7. So when we add those up, we have a total number of 8 electrons that need to be accounted for. I'll write that a little clearer. All right, so step 3 is we have to connect the atoms. So since there is no central atom, we know that these two have to be bonded by at least a single bond. So again, that single bond represents 2 electrons. The next step is to place electrons around each atom so that each atom has or shares 8 electrons. Hydrogen is our exception. Since hydrogen is in the first energy level on the periodic table, there are only 2 elements in that energy level. So hydrogen can only ever share a single bond. Bromine, we would need to add more electrons, so it would have 8. So here's 2, 3, 4, 5, 6, 7, 8. So then we need to check with our 2 questions. The first one, do all atoms have or share 8 valence electrons except hydrogen? And the second question is, does the number of electrons in my drawing match my calculated value? So hydrogen is sharing 2 electrons, so it's good. Bromine is sharing 2, 4, 6, 8, so it's good. Total in my drawing, I have 2, 4, 6, 8 electrons, which matches my calculated value, so I'm done. All right, next example, SO2. Sulfur is going to be my central atom. The central atom, again, is usually in either group 4, 5, or 6, or it's going to be usually the element that has fewer numbers of atoms. So here we have 1 sulfur, 2 oxygens. So sulfur will go in the middle, the 2 oxygens will go on each side. So that's step 1. Step 2 is we add up the valence electrons. Sulfur has 6 valence electrons. Each oxygen has 6, and we have 2 oxygen atoms. So we take 6 times 2. So 6 times 2 is 12, plus 6 more is 18. Step 3 in our drawing is to place a single bond between the central atom and all other atoms. Step 4 is to add electrons so that all atoms either have or share a total of 8. So here's 2, 3, 4, 5, 6, 7, 8. Sulfur is sharing 2, 4, 5, 6, 7, 8. And this oxygen is sharing 2, 3, 4, 5, 6, 7, 8. So now we can do our step 5, which is check asking those 2 questions. So first, do all atoms have or share 8 valence electrons? If we look around this oxygen first, we have 2, 4, 6, 8, so it's good. Sulfur has 2, 4, 6, 8, so it's good. This oxygen has 2, 4, 6, 8, so that's good. So that one checks out. Second thing is, does the number of electrons in my drawing match my calculated value? So if we count all of them up, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, that does not check out. So now we need to go back and fix our structure and add a double or triple bond. So since both of these are oxygen, it doesn't matter which side we add the double bond to. So I'm going to add the double bond here. Once you add the double bond, then you have to start taking away some of those extra electrons. So this oxygen now would have 2, 4, 6, 8, 10. So I'm going to take 2 of these off the side. Sulfur right now has 2, 4, 6, 8, 10. So it has too many. So I'm going to take these bottom electrons off. So instead of sulfur and oxygen both having their own set of electrons, Now they're sharing these two. So this bond gets counted for oxygen and sulfur. So that's why we can go back and erase those electrons. And then oxygen over here has 2, 4, 6, 8. So it's fine. So now we have to go back to step 5 where we check. Oxygen would have 8 electrons, so it's good. Sulfur would have 8 electrons, so it's good. This oxygen has 8 electrons, so it's good. Now we have to double check our drawing to make sure it only has 18. 2, 4, 6, 8, 10, 12, 14, 16, 18. We're good. All right, the last one is SCl2. So again, sulfur will be our central atom because there's 1 sulfur and 2 chlorides. So step 1 is find the central atom, place all the other atoms around it. Step 2 is add up your valence electrons. So sulfur has 6 valence electrons. Each chlorine has 7 valence electrons, and we have 2 chlorines. So 2 times 7 is 14, plus 6 is 20. Step 3 is we add a single bond between the central atom and all the outside atoms. Step 4, now we have to add those extra electrons. So chlorine right now is sharing 2 from that single bond. 3, 4, 5, 6, 7, 8. Sulfur has 2, 4. So I'm going to add 5, 6, 7, 8. This chloride has 2, 3, 4, 5, 6, 7, 8. So now I can do my checking. Make sure all atoms have a total of 8 valence electrons and make sure our drawing matches this number. So chlorine has 2, 4, 6, 8. Sulfur has 2, 4, 6, 8. And this chlorine has 2, 4, 6, 8. So the first part of step 5 checks out. In the total drawing, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We're good. So hopefully that helped. I will also include a drawing of the next 3 examples as well so you can check yourself. You're doing a great job.